I wasn't scared. I was just wondering how this works. Do you know how this works?
No idea.
Maybe we should ask someone.
Well, I know just the guy.
This amusing. Care to explain everything?
How this works?
How to get inside?
How inside works?
Okay, sure. Sure, we can do that, right?
Yeah, you can do it. These emergency lamps are used when there is no electricity to get lights.
Don't you think we know that already?
Right. Yeah, you know. Okay. Yeah. Well, this bulb, this emergency lamp has 3 states. Here in this switch, if you put it in the middle state, it will always be off. But in the down state and the up state, up here, the bulbs are light up. Bulbs will light up if this is not plugged in. Okay. But in the down mode, only one bulb will light up, and in the up mode, both bulbs will light up.
Now let's see how to get inside this.
First, we have to remove these bulbs because they are very fragile. Like this, we have to turn the bulb around and remove it from the bulb holder. Now we have to unscrew these screws to get inside.
Then open the wire holding chamber.
There are 4 main parts in this emergency lamp. This one is the battery, and this one is the circuit board, and this one is the transformer, and this is the bulb holder.
Now let's take these things apart. First we have to unscrew the circuit board from the main body. Now let's remove the battery from the circuit. This is a LED battery. Charging voltage is 7.2 volts and standby use voltage is 6.75 volts. This is the main circuit board, and this is the switch that we talked about earlier. This is the transformer which steps down the 230 volt supply into 10 volt.
Now let's go to the simplified circuit diagram of this circuit. First, in this section of the diagram, you can see the main transformer and the rectifying bridge. In here, the home supply 230 volt AC input to the transformer, and we get 10 volt AC output from it. Then it goes to the rectifying bridge and gets around 8.5 volt DC output.
Now let's move to the regulating and battery charging part. The output of the rectifying bridge goes to the D1902F amplifier transistors collector for regulating. The output from the emitter is around 7.2 volts. As you can see here, that output goes to battery's positive side, since it should be charged by sending 7.2 volt current through it.
Now let's move to the switching part of this circuit. As you can see in this, from here switching part is connected to the battery and the external power supply. When there is power from the external power supply, voltage here will be higher than when no external power supply. So when no external power supply, it causes the first op amp to give low output and it makes the second op amp to give a high output, which triggers the oscillation part of the circuit.
The next part of this circuit is the oscillating. Since in this lamp we use the tube lights, oscillation plays a very critical part in this. First of all, we should understand why we need oscillation. The tube lights works only in AC current. Since we turned supply voltage of the lamp into DC, we have to turn it back to alternating current. After the output of the op amp goes to the oscillation path through here, it triggers. This part of the circuit acts as a tank circuit which drives the oscillation. This oscillation part was designed that this oscillation happens at more than 20 kHz frequency, so that humans can't hear the noise. The output from the TR200 transformer goes to the tube lights through these capacitors. Thus ends the current flow through the circuit board. These two switches here gives the three functions I mentioned in the beginning of the switch. Now let's see how this emergency lamp can be improved. If we could use LED bulbs instead of tube lights, we could save a lot of energy. And also the complexity of the circuit will be much less. And also weight and size of the emergency lamp will be much, which makes it more portable.
Well, that's how it works inside.
Well, now you got it, right?
No. But you got it right.